Take a look at these gleaming beauties, will you? They're all AGP video cards that I bought recently in a big bundle for about €5 each. There's everything from an ATO Radeon 9550, 9500, 9600, a couple of Nvidia 6200s, there's a Geforce 2MX, there's even a couple of Geforce 4s, this is the MX420 and MX440 SE. Now, instead of benchmarking all of these on the channel, what I'm going to do today is something a little bit more interesting. Instead of installing the standard benchmarking suites or a bunch of games, I want to experience the features of these graphics cards for myself using OpenGL, and for that I'm going to need a machine that I can install Windows XP on. So I've chosen my Pentium 3 1.45 GHz machine with the 2-Latin core, and just for now I've installed the Radeon 9550 card. Before I set everything up, let me address the elephant in the room. Why am I not using a Pentium 4? After all, that Radeon 9550 card came out in 2004 or so, and there were certainly plenty of Pentium 4s by then. Well, maybe it's just me, but I prefer the Pentium 3. When the Pentium 4 first came out, it had a reputation of being a bit of a heat hog, and you had to optimize your code, especially for this CPU, otherwise it ran pretty much the same speed as a Pentium 3. In fact, it gained a reputation of being one of the worst processors ever released. Let me know in the comments if you think I'm being a little bit unfair. Now, I normally have Windows 98 on this machine, but some viewers have said that's a little bit early for these late graphics cards. In fact, it can be difficult to find drivers at times, and it's probably not giving those cards a fair go. Of course, there's always Windows ME, and well, maybe it's just me again, but I think that's a stinking pile of garbage. So the next logical choice would be Windows XP, and I certainly have original copies of this. There's no problems at all me installing this on the machine. The difficult for me with XP has always been the activation procedure. The servers don't work anymore and you have to ring up on the telephone. I get that in German, of course, and there's this enormous long number that you have to type in, which you almost inevitably get wrong. And then if you change the hardware too much, which I'm doing all the time on the channel, then of course the activation is worthless and it runs out after 30 days. Well, I found an ISO on archive.org that doesn't seem to have these problems, so I'm just installing from that at the moment, and it really solves a problem for me on the channel. Well, Windows XP seems to have installed just fine, and it works great on this PC. I'm certainly not going to store my credit card details on here or take it on the internet, but it's going to do just what we need. Now, of course, we need a driver for the video card, so I'm going to use the AMD Catalyst driver for that. Now, I'm really not sure what the cool kids today would use for the Windows compiler. We need something that's going to use the Windows drivers so that we get hardware acceleration in OpenGL, but it also all needs to work with Windows XP. Now, PellesC is what I used back in the day when I was doing OpenGL programming, and even though it's maintained to this day by its author, Pelle Arrhenius, I still had to go back to 2013 to find a version that still supports Windows XP. There's a link in the description if you want to follow along and install all of this for yourself. And then we need to install the OpenGL Utility Toolkit, better known as Glut, originally written by Mark Kilgard and ported to Windows 32 by Nate Robbins. This still seems to be available on the web, and there's a link in the description if you want to get it. And it comes with an amazing collection of OpenGL examples and demos that we can build for ourselves using PellesC. There's a few files that need to be put in specific locations for PellesC, but I give all of that information in the description below. Then we should be able to open up the examples directory that came with the glut distribution, and for example, if I want to build the glut.dll example, I just open it in PellesC and then make a project out of it by clicking build glut.dll.c. And all the source files will be shown on the right hand side here, and we just need to make a couple of changes to the project options for the compiler. Normally there's level 1 warnings, and these are a bit annoying, so I turn those off. And then we enable Microsoft extensions and define compatibility names, which gives us the greatest compatibility with this compiler. And then it's just a matter of building the project. So build glut.dll.exe, and when it's done, we have an actual console app that we can actually execute. And so now we have an OpenGL dinosaur that we can rotate with our mouse. Pretty cool, huh? The examples are great to learn from because they're usually straightforward. For example, this sphere2.c draws two shaded OpenGL spheres on the screen, And if we look at the source code, it's just a single file, sphere2.c. If we double click it, we can see that it's really quite short. Most of OpenGL programming doesn't require a lot of programming knowledge. You just need to learn what these glut functions actually do, and then you're away. So let me show you some of the other examples. This example is called Molehill. It just distorts 4 squares and then shades and lights them with OpenGL, and it looks really cool. It's not interactive, so nothing happens when you move the mouse, but this is just a straightforward example program. I'll show you some more sophisticated demos shortly. I like this example. It's got an icosahedron in it that I might steal for myself, and when you move the mouse over the objects, they get shaded. Now, this is 350 lines of OpenGL programming, so this might be pushing people who are beginners, but once you get past that beginning stage, there's lots of cool examples like this to follow. Now, I won't spoil all the examples for you because maybe you want to build some yourself, but let me show you how to build the demo programs. So these are in a different directory which I've called OpenGL, and each is in its own subdirectory. And that's because they're quite large. There's a lot of source files and even some asset files, point meshes and texture files and so on. So let's suppose I wanted to build the geoface demo. I won't do it here in the open dialog. Instead, I'm going to do a new project. And it'll be a Windows 32 console app as normal, and I'll set the location to that top level OpenGL directory. And you can see all the subdirectories here, and there's our geoface one. And to tell it to use that geoface directory, I'm actually going to call the name of the project geoface, and that causes PellesC to build the application in the directory called geoface, which is what we want, because then the executable file will be right where all the asset files are. So let's click OK, and it'll ask us whether the project already exists and whether we want to replace it. We just click yes. And now we add files to the project. So there's quite a few source files for this project. So I just open them all and it'll append them to the project. And now I just need to set my project options as normal. So no warnings, enable Microsoft's extensions, define compatibility names, and I should be ready to build geoface. Take a little bit longer than the example files because they're much larger, and then I can execute it. And look at that, isn't that cool? So this is a face rendered using quite a lot of polygons and some asset files, of course, in OpenGL. And this actually runs at a normal speed because it's got to do quite a lot of work here, and also I'm controlling it with the mouse. I'll show you a few more of these demos, but I don't want to spoil all of them. This blue pony one's obviously running too fast. It's mainly because the pony's quite small and it's the only thing moving, and obviously we have that really overpowered graphics card in there at the moment. It's much the same story with a lot of these. This flare demo is also way too quick. What we'll do is we'll put in one of the slower graphics cards shortly, and we'll see how much difference that actually makes. Even very complex moving scenes like this glut mech are way too fast on this graphics card. And this is nearly full screen as well. What we need is a demo that displays a frame rate so we can compare that between the different graphics cards. Anyway, while I'm here, let me show you some of the interactive things you can do with this. You can stop him walking, and there's a little menu here which tells you how to move the various parts of the Mac just by pressing keys on the keyboard. Of course, you can start him walking again, and you can also toggle wireframe mode, which shows all of the triangles that are being rendered. It's really quite impressive. And of course, you have to create scenes like this using something like Blender and then import the objects into your program, and then you do all of the shading and lighting, the camera angle and the reflections, movement and so on with the OpenGL functions. This particular demo is either set to run at a specific rate or it's actually taxing the card more than the other ones. It seems to run at a more normal speed, and it's really pretty impressive. It has these really cool pipes that rotate about, and there's shadows as well. Not only that, there's some really cool lighting effects going on here. So I'm really impressed with this one. I think this is probably one of the better demos in the lot. Here's another one that doesn't run too fast, and the good thing here is it actually has a frame rate counter. And as you can see, it's 225 frames a second or so, and I can also rotate this about with the mouse. So we should be able to try this out with some of the other graphics cards and see how they compare. So let's go ahead and do that. Well, the next card that I decided to try should be the slowest of them, the Geforce 2 MX. And yeah, look at that, it's only getting about 50 something frames a second. I think it mostly is at 50 and occasionally goes up to 56. So that is a much more reasonable speed. So I wonder if some of those other really fast demos will actually run at normal speed with this. Ah, yeah, that's much better. This is the Blue Pony going at normal walking speed. And I guess this shows that you don't need a very powerful graphics card to get started with OpenGL programming. You'd only need that if you had a lot of movement everywhere on the screen and you're using a lot of complex effects. Actually, this glut.max still looks too fast to me, even on this Geforce 2 MX card. I imagine these OpenGL demos were written in the very early days of OpenGL, before things really started getting going. I'm probably going to have to find some later demos from somewhere that show off the later features, like the vertex shaders and so on, and that's probably going to have to be a topic for another video. Now, I'm not really sure whether the Radeon 9600 or the Geforce 4 would be the faster card, but unfortunately we can't try the 9600. For some reason it just returns an error code when I try to run the particle demo, and this means that it's not actually initializing the OpenGL properly. In fact, even the ATO control center doesn't actually run with the driver supplied with it, so I don't know what's going on there. But let's try out the Geforce 4. This is the Geforce 4 MX420, and as you can see, it seems to have a few problems on this system. Unfortunately, it's also using software rendering for OpenGL. You can tell from the really low frame rate of 20 frames per second that we're getting, which is way lower than what you'd expect if it was using hardware rendering in the driver. Now, I've tried a few different driver revisions and it doesn't make any difference. And in fact, I'm having the same problem with the Radeon 9600 card. So it seems these later cards just don't work very well with OpenGL and glut on Windows XP. Either that or I just have a bunch of faulty cards. And in fact, the other card that should be fast is the other Geforce 4, but it seems to be faulty. It doesn't even boot up on this machine. It probably explains why this bunch of cards was so cheap when I bought it. Oh, I did manage to get the 9600 working. I went back to a much older driver revision than the one that AMD recommends you run. And we're getting about 225 frames a second here, just the same as for the 9550. Sorry about the noise in the background. This is due to a broken fan on the 9600. That's something that I can easily swap out, of course. So, looks like I have a couple of good working video cards from this batch. In case anyone's wondering how the Nvidia 6200 does on this machine, I've got about 50 frames a second here, which seems a little slow. It could be a hardware rendering speed if the card is just a really crappy one, but this is more than likely a driver issue. It looks like it's installed correctly, unlike the Geforce 4, but I can't get it to go any faster than this. Anyway, this video is already getting quite long this week, so I'm going to make a break here, and in part 2 I'm going to come back with some more OpenGL demos that you can build for yourself to learn OpenGL programming. And then I'm going to give it a go and see what I can manage to do. So until then, thanks very much for watching. Don't forget to like and subscribe if you haven't already, and put the notifications on so you know when I upload a new video. And we'll see you in a later video. Bye.